Carlos, do you want to kick us off? I feel like we have a decent amount of people joined.
I think we can start. Carlos, did you hear Catherine? Okay.
Hello, everybody. Good afternoon, good morning, good evening, depending on from where you are joining. Welcome to this GMI Biogas Subcommittee workshop series. Today, we will discuss understanding your waste stream to develop methane reduction strategies. It's the third webinar on, under this series. I'm Carlos Silva Filho. I'm currently the president of the International Solid Waste Association, and I'm honored to moderate this afternoon's webinar. And thank you very much for joining us for this afternoon, when for sure we'll have very interesting presentations and discussions with our guest speakers. So today we will have a panel talking about GMI, methane GMI and GMI tools by Clara Zimmerman from the US EPA. Then we have a waste characterization by Sandra Mazonix from Abt Associates, a case study from Canada presented by Hussein Zak, and a case study from Wisconsin presented by Casey Krausensky. So I'm happy to hand it over to Catherine Hush before we just jump into our speakers. So thank you very much.
Thanks, Carlos. And thank you all for joining. Before we start, I'm just going to go over a few webinar software tips. So first, there are two ways to connect with the audio today. You can either listen through your computer speakers, or you can use the number that is posted on the slide. All participant lines will be muted for the duration of the webinar, regardless of the audio method that you choose. Okay, so for today, we'll be using three panels for the webinar. These are the participant panel, Slido, and the question and answer panel. All of these can be found on the right-hand side of your screen, and you may need to click the arrow next to the desired panel to expand and see all of the content. If for some reason one of them does not appear, you can navigate to the bottom right of your screen and click on whatever you are missing. So we will be asking a few poll questions during today's webinar. The Slido panel will appear when we open the first poll. You can simply select your desired answer and hit send. And then at the end, we will also have a few feedback questions, and we appreciate your feedback and we'll use it to inform future webinar planning. And then lastly, throughout the duration of the webinar, you can enter questions into the Q&A panel. When submitting questions, please select all panelists from the drop-down menu before hitting send, as this will ensure that all of the speakers can see your question. These questions will be moderated at the end of the webinar during the Q&A session. The final materials from today will be posted to the GMI website. And with that, I will pass it over to Clara from EPA.
Thank you, Carlos and Catherine. Appreciate it. So Carlos went over the agenda, and I will move into our intro to the Global Methane Initiative and the Biogas Toolkit. So I'll start just with an overview on methane. So since the Industrial Revolution, global atmospheric methane concentrations have sharply risen, and as you can see in the graph on the right, like carbon dioxide, methane is a greenhouse gas that traps heat in the atmosphere rather than letting it escape, which causes an overall rise in temperature. And methane also contributes to formation of tropospheric ozone, also known as ground level ozone, which is an air pollutant and a greenhouse gas. So methane is considered a short-lived climate pollutant that only remains in the atmosphere for 12 years, which is a much shorter time than carbon dioxide. This means cutting methane now is a really important opportunity to immediately slow the rate of climate change, and capturing the methane and converting it into clean energy can also enhance energy security. So, in response to that opportunity, the Global Methane Initiative was formed. We're actually celebrating the 20th anniversary this year. And GMI is an international public-private partnership focused on advancing cost-effective methane mitigation projects and reducing barriers to recovery and use of methane as an energy source. So we accomplish this mission by providing technical support to deploy methane to energy projects around the world. And GMI works in 3 key sectors: biogas, which includes municipal solid waste, agriculture, and wastewater, as well as coal mines and oil and gas. The US EPA is a founding member of GMI, and we provide in-kind support to develop tools and resources for GMI, which is why I'm speaking today. So in terms of those sectors, municipal solid waste is the 3rd largest source of global methane emissions caused by human activity and contributes to roughly 12% of all emissions. In the municipal solid waste sector, methane is primarily generated through the decomposition of organic waste like food waste and green waste in oxygen-free or anaerobic environments like dump sites and landfills. And if you've been with us for the other webinars in the series, we've covered this, but food and green waste make up about 44% of the global waste stream, according to the World Bank. And because that waste generation is expected to increase by more than 3 times by 2050, reducing methane in the waste sector is a really key opportunity to mitigate climate change, but also to deliver co-benefits like better air quality and improved human health by improving solid waste management. So EPA's Biogas Toolkit houses resources that were created as part of our work on methane mitigation through GMI and other programs. And the toolkit includes many resources which are helpful for municipal solid waste decision makers interested in methane abatement. It's for educating all stakeholders on the appropriate steps in project development and aims to improve project success and reduce risks, etc. So on the next slide, we'll learn more about some of these tools in the toolkit. These are the Global Methane Initiative developed tools, and all of these are Excel-based tools that were developed separately and serve as standalone tools, but they're related in their shared goal to mitigate methane emissions through the abatement, recovery, and use of methane. So this presentation will focus on the new GMI Waste Characterization Handbook and Tool to understand waste stream compositions and how that data can be used as inputs for the other tools presented here, like the Solid Waste Emissions Estimation Tool, or SWEET, Anaerobic Digestion Screening Tool, Organics Economics, and our Landfill Gas Screening. Sandra from APT is going to talk a little bit more about this, but just as a quick overview, the GMI Waste Characterization Handbook provides information for city decision makers and solid waste professionals to plan and conduct a waste characterization study. So the handbook includes recommended activities and resources to plan an appropriate type of study for your specific site conditions, and field activities to collect the data and analyze that data to make informed decisions. And then the accompanying tool can streamline data entry and help easily analyze the composition. The recommendations are based on GMI and its partners' real-world experiences, such as a waste characterization conducted in Gurugram, India by the US EPA, which I will talk a little bit more about. We have a few mini case studies in this webinar today. So this is the first one. So in 2019, the Municipal Corporation of Gurugram, India worked with a team of experts from EPA to conduct a waste characterization study. That study was designed to capture detailed information on the type of waste received at the Banwari landfill, which receives waste from the twin cities of Gurugram and Faridabad in India. So the city had plans to develop a waste to energy facility, and the landfill study was designed to help evaluate that energy potential. The study showed that 32% of the waste disposed at the landfill was organic, and that demonstrated the need for organics treatment was more important than an incineration project. The fraction of waste that could be combusted in the proposed waste to energy facility was quite low. And as a result, the city is asking bulk waste generators like high-rise residential buildings to manage their own organic waste. So accurate local data from the study helped the city avoid investing in a waste treatment facility that would lack the sufficient feedstocks. And as an additional outcome from this, the people trained in waste characterization conducted multiple other waste characterizations, including performing more detailed characterization studies. GIZ conducted studies at Kanpur and Port Blair that resulted in waste management action plans for those cities. And I will turn it over to Sandra.
Thank you so much, Clara. Hello, everybody. My name is Sandra Misonex, and I'm an experienced environmental manager with over 16 years of experience in municipal solid waste management, climate change, and greenhouse mitigation. I hold an MS degree in environmental science and policy from George Mason University and a BS from management engineering from the National University in Columbia. My current role is serving as solid waste management senior associate at Up Global, and I have also worked as program manager at CCAC, the Climate and Clean Air Coalition. But let's go ahead and get started talking about waste characterizations. Well, many of you might be familiar with waste characterization. We would like to offer a brief overview about what are waste characterizations, and then we will also, I also intend to introduce the waste characterization handbook and Excel tool that Clara was talking about. So, but before we get started, I would like to, we have some poll questions for you. So if you can please answer those.
Yeah, so we will do these one at a time. I've just launched the first question. If you don't see it appear, you can click on apps in the lower right-hand corner of your screen and then Slido. So yeah, we'll just wait a second for the first question to be answered. And then we'll move to the second.
Okay, the first question basically is to let us know what is your primary industry or field of work. And
yep. And we have 21 votes right now, and it looks like 62% of people say academic, researcher, or NGO, 26% say federal employee, and 12% say state.
Okay, and then so we have a lot of people working with NGOs. And can you please launch the second question just to know what would be the current knowledge level of waste characterization?
Yep, that question is live. Okay, right now we have 28 votes. 3% say 1, no knowledge, 20% say 2, 45, 3, 23%, 4, and 10% say 5, expert knowledge.
Oh, wow. We got all kinds of experts, and we're glad you're here, and we hope that you can learn something from this presentation. Well, let's go ahead and talk a little bit then about municipal solid waste, and then why is it necessary to do waste characterizations. As most of you know, waste can vary significantly by country, region, and local demographics. As one example, the chart on this slide illustrates global waste composition and how it varies by income level. As you can see that as the level of the income level increases, food waste as a share of MSW decreases, and while the other materials like paper and glass increase. This is important to know what is being generated and what is going to landfills or disposal sites, because basically, like Clara mentioned, the uncontrolled decomposition of organic waste basically contributes to methane emissions. So it is important to know what is being generated so we can take the effective solid waste management strategies to mitigate methane. One thing that is important is that accurate data on waste stream is crucial to planning successful municipal solid waste strategies and understanding the effectiveness of existing programs. However, most of the time we see that their data that is accurate and current is very much lacking. So this is an important thing to keep in mind. So waste characterization studies provide high quality waste stream data that can inform MSW strategy choice to support methane mitigation, especially when considering new programs or projects. So what are waste characterizations? Basic waste characterization is a systemic approach to understand the composition and proportion of each material or product in the waste stream. For example, the amount of plastics, the amount of organics. And developing waste management projects without a clear understanding of the waste stream and its composition can lead to numerous problems, ranging from suboptimal operations to project failure. Waste characterization studies provide real-time information about the types and quantities of materials that are being disposed at a certain location, which can then be used to estimate the waste generation from neighborhoods, cities, or actually entire regions. This data actually is very useful to facility operators, government officials, and researchers, and can have different uses. So I'll discuss these uses in the next slide. They can also, waste characterizations can also help assess the trend of the waste generation being done over time. And this actually can also inform policy, technologies, and the communications with the public. So there are numerous applications to the waste characterization data. And in many cases that the studies are used to design programs and policies to divert waste materials from disposal, but there are other uses as well. One key use is to establish baseline waste management conditions. And this is necessary to understand and to measure the progress and effectiveness of existing solid waste programs, as well as providing information on the current waste management systems, such as diversion and disposal conditions, which can then be used to establish goals for reducing and diverting waste. A key use for the waste characterization from the baseline is basically to provide data points to model the landfill gas emissions if the data in the waste characterization is being done at the landfill. Also, the data can be used to develop reduction and diversion strategies. So you can use the data to identify what is the largest material streams and then use that information to focus the diversion efforts for the most cost-effective measures. You can also use it to select the appropriate technologies that you're going to be using for the waste treatment. So it could be like if you're going to decide that you're going to divert organics, then you're going to see whether it will be better to use composting in case maybe if you are only diverting yard waste, or maybe if you're doing a bigger project when it includes food waste, then you might be consider using anaerobic digestion. This is also important for project sizing and capacity planning for when choosing a technology. Likewise, you can use the data to understand the contamination of your waste stream. So if you have already separated waste streams, then you can see, for example, if you have an organics waste stream, then you can see whether what is the level of contamination, how the program is working. Like what if you also have for recyclables, you can also see how many of those waste that are being, if there's contamination in that stream and how much is it and what you can do about it. And lastly, so that all is you can also use that information to, like I said, evaluate and improve programs. And also you can also use the information to compare between facilities and also to see how basically a city or a region is basically doing compared to the national. Now let's talk a little bit about the different types of waste characterization studies. So you can have waste, one is waste generation versus the collective. And outside that waste generation study, you can have those done basically at the household level, maybe at the industry, at the commerce or institutions. So there are very diverse methodologies to do this type of waste characterization. Likewise, you can do waste characterization at the waste collection sites, for example, at the transfer stations, at the landfill, at the incineration plants, or at the treatment facilities, for example, at a composting or anaerobic digestion plants. And you can also have waste characterization done at where waste is being accumulated, for example, at beaches, waterways, or mangroves. And here in the picture, you can see a picture of a accumulation of plastic waste. Well, it could be other types in a waste stream. Another type of waste characterization is basically can be done by materials. So you can actually do a waste characterization of the organics that are being disposed, or the plastics, and then in that you can actually maybe see how many of them are packaging versus single use, and like we mentioned earlier, to see what are the contaminants in a waste characterization. Another waste characterization type of study is by product brands, and there are several examples out there. For example, you want to see in a country, they want to see how much of the waste is basically from imported materials or imported brands, and then they're also being used to establish EPR, extended producer responsibility program. So those are very important as well. So talking a little bit more about the waste characterization handbook and Excel tool that has been developed by GMI. So the handbook provides information for city decision makers and solid waste professionals to plan and conduct the waste characterization study. The handbook includes recommended activities and resources to help city and solid waste professional plan an appropriate type of study for their specific site conditions, conduct field activities to collect the data, and analyze the data to help make informed solid waste planning decisions. The waste characterization tool, which is an Excel-based tool, that streamlines data entry and analyzes the composition of different waste streams, identifying the study. So the handbook guides the reader into 3 main steps to do a waste characterization. In each step, the handbook recommends the necessary tasks that need to be done. So in the planning step, the handbook discusses the importance of setting the goals and objectives that establish the reason for the study and the desired outcomes. Likewise, the handbook describes the considerations necessary to design the study, like establishing who has control of the waste material, the sectors generating the waste, the location and time to conduct the study, what are the potential costs, and identify other key stakeholders, like, for example, the formal or informal sector waste workers. This step also goes over the main aspects of developing the sampling plan and creating a staffing plan. In the field activities step, the handbook goes into the main tasks, such as training the staff, gathering the necessary equipment for sampling, also setting up the sampling and the sorting sites, conducting the waste sampling, so doing the sampling per se, and sorting and weighing the waste material, which is basically where you're going to see what materials are being generated or disposed. For this step, the handbooks also provide sample templates and communication materials that can be used during the field activities. And these communication materials will be used with the site facility. The tool can be used for the data entry of sampling. So you can use the Excel tool during this step. And lastly, for the data and results step, the handbook explains how to conduct the data analysis, including calculating the percent composition, and guides on how to interpret the data and determining the results and incorporate the results into waste management activities. So this slide basically shows what it will be the cover of the tool, and then it also has each of the tabs will correspond to the different steps of the handbook. This slide basically shows is an example of what you can see in the results tab, where it can show you what is the waste by composition day by each day that it was done in the sampling, and then also by the different waste generators that if you chose to do it by waste generator, and then you also get some graphics on what basically the results are going to look like. Like Clara mentioned, basically this information could be used with other GMI resources. So you can the data of the tool can be used for UnSuite to see what are estimate the baseline emissions, and then you can use that information for the proposed scenarios and see what would be the best what would be the best measures to take. Also, you can use the data and the anaerobic digestion screening tool to understand if a specific organic feedstock could support an AD project, and also utilize the landfill gas screening tool to see how much gas a site may produce and if the supply could support landfill gas energy projects. In summary, the data generated by the waste characterization study provides accurate, local, and timely information that is extremely valuable to solid waste management operations as they evaluate alternative strategies and assess their feasibility, understand their emissions, and more. So the guideline is a great tool to basically do that. It will walk you through all the steps necessary and all the tasks that need to be done. It includes templates to use, so it will make it easy, and also it will include some letters and memos templates to communicate with the site and with people. And that's it for me. I'll turn it over to Hussein.
Thanks, Sandra. Hi, everyone. My name is Hussein Zaki. I'm a project engineer with the Environment and Climate Change Canada, which is the environmental department in the Government of Canada. And today we'll sort of show you a bit around the work we've been doing on waste characterization nationally. And typically, when we have conducted this work in the past, the waste management duties sort of fall on the subnational entities here in Canada, the provinces, and so on. So as a federal government, we sort of deal with any waste characterization work past the stage where the waste audits have been conducted. So really getting the data from those waste audits and waste audit reports that have been conducted locally in Canada, and sort of using that data for our own purposes. So our work started off sort of as a necessity to support two ongoing programs here at Environment and Climate Change Canada. The first one is the national inventory reporting that Canada has to do every year to the UN as part of declaring all the sources of GHG emissions. And part of that is estimating the methane and GHG emissions associated with the disposal of solid waste in Canada. And so in order for these assessments to happen, we needed to sort of explore the composition of the different waste streams here in Canada that are disposed in those landfills to be able to support the modeling of the methane generation. And the second reason why we started this waste characterization work, as well as what Sandra spoke a bit about in terms of supporting diversion policies and so on. So our group, the Waste Reduction and Management Division, we're responsible for putting in place policies that support the diversion of the solid waste away from the landfill to other uses. And supporting these municipalities, we also need to understand sort of the composition of how much of the biodegradable materials end up in the landfills, how much of it can be diverted away from the landfills, and the infrastructure that is required to process this diverted waste. As a federal government, we try to explore these metrics in order to be able to properly set up funding programs and put policies in place. So as a national entity, as the Government of Canada, we needed sort of a national number of the composition of the residual waste stream or the garbage waste stream the what we call the blue box or the recycling stream, and then there's a biodegradable/organic waste stream. So in order to get a metric for these three streams, we needed to sort of gather as many studies that were done locally at the municipal level in Canada as possible, and sort of aggregate them to a national level to be able to get that national profile. And to do that, we, considering how expensive these waste audits are when they're conducted, how much they cost, we are sort of a bit short on the resources to actually conduct these audits, but or even sort of get in an agreement with a municipality where we would purchase the data and so on. So what we rely on is the voluntary submissions of those municipal waste audits by those municipalities. So that entails building sort of a relationship between the federal government here at Environment and Climate Change Canada and some municipal contacts at the city level, at the regional level in Canada, to be able to correspond with them and be able to receive any waste audit or waste characterization reports that they've conducted in the past years. So typically, municipalities send us, different reports that they've conducted for different years, so the years don't really align. So Toronto, which is a city in Canada, could be sending us a waste audit report that they did in 2021. Ottawa and Montreal and so on could be sending us audits that they did in other years. So our challenge here is to really grab all those municipal audits together, be able to standardize this data so we can aggregate it or sum it into a national profile that we need for our work. And so this is sort of an overview of the National Waste Characterization Program that we have here in place that serves sort of these objectives. Now, in terms of the actual process that we go through once we receive maybe, let's say, a municipal waste audit, is that we first sort of review which sectors this waste audit covers. So we have three sectors of interest here in Canada that we look at, which is the residential sector, the mainly single-family households, multi-residential apartment buildings, and so on. So that's the residential sector here. The second sector is the ICI, it's industrial, commercial, and institutional sector. So we try to collect waste characterization or waste audit reports specifically done on commercial businesses, offices, and so on. Now, there's a lot less of those compared to the residential one, because most of the audits that we receive from municipalities here in Canada, these are samples that were taken from a sample of houses in the municipality. So typically they just cover the residential sector. Very few audits actually include also the auditing of commercial businesses and so on. So we sometimes have to resort to other means to get audits that were conducted in the private sector, because they're not always willing to share it based on or depending on their performance. But we try to maybe work with engineering companies here or consulting companies here in Canada that usually conduct these audits for these businesses, and try to work out an agreement where confidentiality of the organization or the business can be sort of remain confidential, and then its data only used in the sort of aggregation process. So any data or any report that we publish later on can only be published at the national level and does not contain any confidential information. And I'll also mention on the previous slide, so our program, whenever we sort of do these data calls, or every 2 years or 3 years, we sort of do this data call out to all the municipal contacts that we have here in Canada, and with the partnership of a federal, I guess, coalition or Canadian Municipal Association that helps us usually in reaching out to those municipalities in Canada and encouraging them to submit their data. When we do this call out and we have gathered sufficient data, we sort of publish a national or provincial level report. So the latest report that we had published was in 2020, and it's called the National Waste Characterization Study. And it essentially contains, and I'll show you a sample of the results in the next slide, but it contains sort of a profile for each province here in Canada based on the audits that were collected. And all the data is usually aggregated, like I said, to a higher level so that the confidentiality of a business or a specific city is never shown in the report. And so right now we've been doing this call out for data over the last 3 years again. And hopefully we have a target of publishing an updated report that contains this data in 2024 later this year. So we're sort of running through the data right now, trying to sort of analyze it and clean it out. So back to the process. So once we've received sort of a municipal waste audit that has been conducted on the field, we sort of extract its information and data. So typically they're in a PDF format that we just get. So it's a bit, takes a bit of time to extract it to an Excel template that we've set up. And sometimes it's not only the sort of percentage composition quantitative figures that you want to extract, but there's a lot of other metadata or side data from that report that is of use to us that we extracted from these audit reports, such as whether this municipality had a green bin or organics material collection program in place that could influence the amount of food and yard waste or green waste that ends up in its garbage stream and so on. So we try to collect as much information as possible on each of those municipalities that do send us their data. And once we've sort of extracted all of this data into an Excel file for each report, one of the biggest challenges that we've seen is that here in Canada, when municipalities conduct waste audits, they are not using a standardized list of material categories typically. So each municipality sort of has a different list of material categories. And some municipalities go into a lot more detail in their report. So we have very active provinces that do, like such as British Columbia and Quebec and so on, that do actually have cities that audit the different types of plastics. They, in their audit report, they mention a percentage composition for each specific resin for single-use plastics and so on. So these are really the very rich audit reports. But there are other reports that we receive from municipalities that just has a plastics, for example, as a one category, and it's not further broken down. So in order to sort of be able to harmonize all these audit reports together, we create what we call based on like the material categories that we see across those audits, we build a specific standardized structure that we reassign all the material categories that we see in the report to our own Climate Change Canada structure that we've developed in-house. And that structure just looks like a three-level category structure. So the first one, for example, could be the paper category. So that's the primary level category. And then underneath that, the paper category can be broken into, let's say, cardboard, boxboard, and so on. And whatever information we see in those audits, we reassign to the structure. So then we're able to sum up compare apples to apples and sum up the data to a national level indicator. So really the whole objective of this is to get something that looks like this. So I'll skip to the next page, and you can see here, this is one graph that was taken out of our last report. And the objective here is to have these three sectors beside each other. So the residential, commercial, and the construction sector. And for each sector to be able to develop a bar chart or a pie chart that shows the breakdown of the different material categories. In that report, that was our first report that we published. So the material categories were very aggregated or primary level. So paper was not further broken down into the types of paper, plastics, and so on. But in the future report, including maybe this year's and the next reports that we publish, we plan to explore these categories into more detail and try to really break them down with the data that we get from those municipalities. So yeah, I'll stop here. So make sure I don't go over time, and I'll pass it to the next speaker, or Carlos.
Thank you, Hussein. Thank you very much for this great presentation. So now I'll hand it over to Casey Krosensky to tell us the Wisconsin experience. Thank you very much.
Carlos. My name is Casey Krasinski. I'm with the Wisconsin Department of Natural Resources. I'm the solid waste coordinator. In 2020 and 2021, we conducted our third statewide waste characterization study. And I think we have a pretty diverse audience, so I'm just going to give a little bit of Wisconsin background. It's a mid-sized population state and in land area, 5.9 million people. We do have a mandatory recycling law that, according to a survey we did a little bit before or a little bit after the characterization study, actually, 86% of our residents are at least somewhat committed to following. We have a mandatory yard waste diversion law, as well as a mandatory electronics recycling law, but we don't have any food waste diversion requirements in the state. According to the same citizen survey, 81% of our residents are currently putting the majority of their food waste either down the drain or sending it to the landfill as garbage, while 18.5% are composting the majority of their food waste either through a backyard compost or a collection or a drop-off program. So as I mentioned, in 2020 and 2021, we conducted our third statewide waste characterization study. So one of the questions is, why did we take the time and money to do that? And also, you know, it was hired out with a consulting firm. The state didn't actually do it ourselves. But the goals were to identify the biggest problems with what is going to landfills from the state, and you know that could be a couple different things, whether it's space or as focused on here because of the materials creating a large greenhouse gas emission, or just because they're difficult and unsafe for landfills to manage, some sort of hazard. We wanted to get information to identify the easiest fixes, to see, you know, what materials can we that we maybe haven't really educated on before, or that have easy diversion solutions already in place. Because we had conducted a couple of waste characterization studies in the past, we were able to also use this study to see what past laws of our electronics ban happened between our last characterization study and this characterization study. So we were able to see really how effective that was, and same with other education campaigns that we had. Also, you know, people who are in the waste industry, food waste is well known to be a big problem, but when communicating outside of the industry, especially with, you know, legislators or others just in other areas of the Department of Natural Resources, is really helpful to have the actual data to back up just the idea that, you know, food waste is a large methane contributor or a large greenhouse gas contributor. So it's good to have the actual data to put behind that. Also, the department is following the national goal of reducing statewide food waste 50% by 2030 over 2020 numbers. So to see how we're doing on that goal, we definitely need to have 2020 numbers to start with. So we needed to do it to collect baseline data. Because we've done a few studies, we can see trends developing over time, including the fact that we saw food waste is the largest material on the rise of what's going to Wisconsin landfills as far as the MSW stream. And then I don't think I knew, or maybe our program knew, how much awareness it would bring to the waste industry and what we're throwing away in Wisconsin. But it was just conducting this study had great photos, great interest from all sorts of residents. And so we got tons of media requests, you know, print media, TV, radio, And it's really done great things for just making people realize that we can make an impact with waste. So some of the study considerations and planning we included is we were trying to conduct a statewide representative study. And so we ended up doing grab samples, 200-pound grab samples at 15 different landfills across the state, which represents about 70% of the municipal solid waste disposed of in the state goes to those 15 landfills. The majority of them were somewhere larger landfills to be representative that way, but because of rural and urban differences in our state, we also needed to make sure we included some smaller landfills. And similar to what Hussein was just talking about, we did collect data from 3 different sectors, well, 4 actually, but the MSW stream was 3 sectors. And that is single family residential. We broke out multifamily residential as we found usually different types of education is needed between those 2 groups. And then also the ICI sector, the industrial, commercial, institutional. We actually, I know it sounds ridiculous, we actually requested 85 different sort categories for our study. We tried to use standardized terms for all of our plastics that we got from, I think, more recycling. We also tried to retain any categories we had, or most of the categories we had used on past studies, so we could see trends over time. But the primary thing we were trying to do is to break down materials both by our regulations and by disposal options. So, you know, we did do different grades of plastic because different grades of plastic have different abilities to, you know, find markets for them. And we did separate out different construction and demolition waste because some we allow to be used as fill materials and some we don't. So knowing what were actually divertible from the landfill, it was important to get that level of category. And a new category split that we did for this study that ended up being incredibly important is we broke out food waste into 2 categories, one of which was food scraps, what you might think of as going to the landfill, bones, cores, peels, things like that, and what we called wasted food, which is food that was previously edible. And I think even though, you know, the program knew food waste was going to be an issue, and a large amount going to landfills, I think we were all pretty shocked to discover that of the food waste going to Wisconsin landfills, over 70% of it was previously edible food. So not material that has to be thrown away by any means and can be hopefully reduced. And actually that category of wasted food was our largest category by weight of all of the municipal solid waste materials. I also just noted we tried to avoid seasonality when designing our study by having 2 different sample seasons. Wisconsin has, you know, pretty different fluctuations across seasons. We were probably able to do that, but if anyone else remembers 2020 and 2021, we did hit COVID instead. So we know, you know, that our study is a snapshot in time of that time. So analyzing the results that we got, I'm definitely interested to go back and put some of our data into the tools that Sandra was mentioning today. What I used at the time was EPA's WARM model to find the greenhouse gas emission reduction potential. This first bar here is just a line from that WARM model that shows what the greenhouse gas mitigation potential is for source reducing all of the previously edible food waste and composting the food scraps, which is over 2 million metric tons of CO2 equivalents. The WAR model also nicely puts that into some more, user-friendly comparisons. And so it is the equivalent of taking almost 600,000 passenger vehicles off the road for a single year. We use some data from our study as well as some of our modeling results to make this infographic page. You can see some of the standout numbers are that organics make up over 30% of everything that we're putting in the landfill, and wasted food was the single largest category, and the food scraps was actually third. So combined, they're over 20% by weight of the municipal solid waste that we're landfilling. And then this is a bar chart comparing to some of the larger or broader categories to our previous study, about 10 years previous, 11 years. And you can see that the amount of organics going to the landfill has just shot up astronomically. If you want to see the executive summary or all of the details of our waste sort, you can go to dnr.wi.gov and just search waste sort. So what are we doing with the results that hopefully will help with methane or greenhouse gas emissions? We made a residential food waste reduction page. We just are launching a statewide food waste evaluation that will give us both a lot of missing data that we have on where food waste is being generated and the capacity we have for alternative management, as well as action items on how to help with that. We created a new program position to focus full-time on food waste, who will focus on creating an education campaign as well as implementing the actions from the evaluation. And then as a waste program, we traditionally work with landfills, transfer stations, compost facilities, anaerobic digesters, but we realize we really need to be getting more up into the reduction realm to be properly, making the biggest greenhouse gas emission reductions that we can, because, then we're also reducing the emissions needed for transportation, fertilizer, for refrigeration, for packaging, for manufacturing, and processing all of these materials, not just avoiding the landfill emissions at the end. But these organizations don't really have a reason to talk to our waste program right now, so we're going to be contracting a non-regulatory firm to do outreach with places like grocery stores or restaurants or farms who are interested in what they can do. And then we hope to get funding for a food waste specific characterization study in 2026. And I know we're close to time, so just throw out my contact information if people have follow-up. Thanks.
Thank you very much, Casey. Thank you very much for this comprehensive presentation about this statewide characterization. So after the 4 excellent presentations from Clara, Sandra, Hossein, and Casey, we do have some time for questions. Please submit your question on the Q&A panel if you have any. We do have one, a more technical one from Tobias Koch. It's like when using CDM methodology for methane emission calculation, what humidity do you assume for dry waste, as this makes a huge difference? So I don't know, maybe Clara or Sandra, I think it's more related to the tool. If you can answer that.
Yeah, I'll step in. And this is more related to the SWIT tool. The waste characterization tool does not have anything on the humidity for dry waste, basically because what we're doing with the handbook and the tool is basically seeing the components of the waste. So it will be organic, plastic, wood. So what are the components of the waste? So we don't deal with the humidity of it for this tool. The one that does take into account that is the solid waste emission estimation tools, that SWIT tool, where basically we do follow like there is the tool does have the assumptions. So if you download the suite tool, you can see, you can go to the assumptions tab, and you can see what are the assumptions that were have that the tool is using for the estimation of methane and other greenhouse gases. And that has to do more with like reviewing the tool has to do a lot with the local conditions. So what are the climatic emissions? So if there's a lot of humidity in a specific area, you're gonna have you have to change the amount of humidity that certain organic waste has. So for example, wood or leaves or food waste is going to vary accordingly. So I would just say, I would recommend just downloading the suite tool and kind of going through the assumptions tab to really see what is the humidity content that was assumed for different types of waste.
Thank you, Sandra. Thank you very much. And I don't see any other questions in the Q&A. We still have like a 1 minute left. But I do have one question. So like after all these like very good presentations regarding like waste characterization, and one of the challenges we saw from ISWA side when we were preparing this Global Waste Management Outlook 2024 is the lack of data. So how do we raise awareness that measuring waste is important to tackle methane? So I think like if you our speakers can comment briefly on that, because I think this is like very important that we really raise the awareness on like measuring waste and supporting decision making.
I would say for Wisconsin, it really helped us to get the actual greenhouse gas equivalent numbers, to get us talking to climate initiative programs in the state, not just staying in our waste program silo. It suddenly, having the actual numbers drew a lot of attention to the impact that waste could have.
Thank you, Casey. Anyone else?
So I can,
yeah, Hussein, please.
But on our side, I know it's a bit similar to having GHG being the sort of main driver in a lot of our asks in terms of resources and budget to raise this awareness and encourage the conduction of waste audit reports. But I think at the municipal level, from what we've observed, they're really sort of not focused maybe on the GHGs directly, but for them, I think they need to be driven towards the diversion of waste, considering it's, or maybe at least here in Canada, the landfill space available for the disposal of this waste is shrinking every day. So the municipalities are aware of this, and they are aware that in order to properly optimize the usage of the remaining landfill space, they need to sort of take out a lot of the biodegradable portion of it. So in order to do that, they're driven to sort of measure the composition of this waste. So a lot of different factors, but yeah, very, very similar objective.
Thanks, and I can just add, that GMI is focused on capturing and using, biogas as an energy source, and so another way to look at it is how are you then using those organics, for example, in composting or in anaerobic digestion, and in AD it can be used for fuel, for electricity, etc. So and then there's obviously on the plastic side, there's some value in recovering those materials as well. So you have that flip side of characterizing it and what can you use the diverted portions for.
Yeah, I would just add that it's very important to take into account that to do better waste management is important to do the valorization of it. So that could be a motivation. So if you understand your waste stream, you can see what is the biggest streams there are, and then if you can valorize them, then you can have some potential revenue for those.
Thank you very much. Thank you all the speakers for the excellent presentations. Thank you for the comments. It's like sure that we have a lot still to progress, but like a good good initiatives already on the ground. We learned from Canada, from Wisconsin, and like a GMI, and with the tools which are available. Thank you all for the attendees for joining us. We are like past 3 minutes over time, but I think it was like a very, very fruitful webinar. Thank you for like letting me moderate this this afternoon, and looking forward to see you in a future opportunity. So take care, and thank you very much.
Thank you.